Good evening, everyone. Welcome to this tutorial lecture on discrete mathematics. I'm Suryadeep, and today we'll be discussing assignments from week one of previous iteration of this course. So it will help you get an idea of how to solve the problems for this iteration of the course. So I'll be sharing my screen. You can stop me and ask your doubts, or you can ask your doubts at the end as well. So yeah, I'll start sharing my screen. Can anyone confirm if it's visible? Just give me a minute. Uh, I hope you can see the screen. Okay, so someone has confirmed that the screen is visible. So let us get started. These are the questions from the previous iteration of this course on discrete mathematics. So coming to the first question, what will be the number of diagonals in a convex 18 gon? So before we solve for an 18 gon, let us try to see the problem for a smaller polygon. So if let us consider it's a pentagon. So for a pentagon, let us try to solve this problem. So let us call this vertices 1, 2, 3, 4, and 5. Um, so which are the diagonals that you can see? So the diagonals are 1, 3, 1, 4, 2, 5, 3, 5.
Number of diagonals.
Uh, yes, can you repeat what you said? Hello? Okay, so the number of diagon. So what are the diagonals for a pentagon? So if we write it, it's 1, 3, 1, 4, 2, 4, 2, 5, 3, 5, and yeah. So these are the only 5 diagonals that you can see. So but 1, 2, 2, 3, 3, 4, and 1, 5. So these are not diagonals. So none of them are diagonal. These are the edges. So the problem basically comes down to choosing two vertices out of 18 vertices and subtracting the number of edges in a 18 gon. So this equates to choosing 18 two vertices out of 18 vertices would be 18 choose 2 and minus 18. So this is the answer that you will get for the number of diagonals, and if you evaluate this, this turns out to be 135. So option A is the right answer for this question. So if anyone has a doubt in this question, you can ask, or I'll proceed to the next question, and uh, I can repeat it at the end as well if you have further doubts. Okay, so I guess there is no doubt in this question. Let us move on to the next one. So coming to the next question is, which of the following is equal to the number of non-negative integer solution to the equation x plus y plus z plus a plus b plus c is equal to 97. So by non-integer, we mean 0, 1, 2, up, and so on. So 0 is also included in the non-negative integer. So this problem where we have six non-negative integers and the sum is equal to 97, this problem is equivalent to placing 5 ticks among 97 stones. So uh, it is the sticks represent the plus sign and the stones represent the numbers. So it looks something like this. So some um, combinations are um, could be plus and maybe we have placed 3. So
ज्वाइन कर
1
लेंगे अपना कर लिया मैंने
1 2 3 4 5 and let's say one more. So this is one possible combination. So these stones basically represents 4. Let's say this represents 3. This is 2. This is therefore 9. So we have 8. Let's say this is 40. This is 20 and 20. So I think this also adds up to 97. So how many ways we can place this plus and this stones? So the sticks and the stones. So total slots equal to 97 plus 5, that is equal to 102. And in 100 and therefore total number of solution equal to uh, combinations of placing 5 sticks in 102 slots. So that is equal to 102 choose 5. So the correct answer is option B. So okay, now this is the correct answer. So now here it was mentioned that it if it is a non-negative integer. So can any one of you tell that if I made it only positive integer, so instead of non-negative, if I had only positive, and so which means I can X, Y, Z, A, B, C can take values 1, 2, 3, 4, and so on. That is the natural numbers. So in that case, what would be the solution for the same problem if I changed non-negative to positive? Can anyone say? Yeah, someone has said 96C5, which is the right answer. So for everyone else, I'll just highlight why it is 96 and not 102 is while placing this plus signs or the sticks among the stones, we cannot place any stick, any plus outside the we cannot place any plus before the stone. So such a combination like plus 0 0, let's say 0 0 and so on. So this combination is not correct because it would imply we are adding a 0 in front, then a plus, then 3, and then some number, let's say 10, and so on. So the xyz cannot take this value of 0. So the plus cannot be in front, plus cannot be at end, plus has to be in between this 97 stones. And the number of places in between 97 stones is 96. So therefore it is 96 C5. Okay, I hope that is clear. Uh, Let us move on to the next question. So if anyone has a doubt, you can ask now, or you can ask later as well. Okay. Okay. Coming to the third question, I hope this question is visible. If you have any problems in seeing the questions or with my audio, you can tell me. Uh, Okay, so find the number of ways in which you can arrange the letters of the word discrete such that no two vowels are together. So let us first write into consonants and vowels. So discrete is D, which is a consonant, D, I, which is a vowel, S, again a consonant, C is a consonant, R is a consonant, E is a vowel, T is a consonant, and again E is another vowel. So now we'll have to place, arrange the letters of the word in such a way that no two vowels are together. So a wrong, uh, let us first see what is a wrong arrangement. So arrangement such as like this: DIESCRTE. This is wrong because I and E are together. So we don't want such an arrangement. We'll have to place such that there no two vowels are together. So how will we do that? So to do that, wait, we'll first create, we'll first write down the consonants by giving some space. So we create one space before D and after each of the consonant, before and after. So D, S, C, R, T. So we have 5 consonants, and if we place the vowels in any of these slots that you can see, then we will have the correct arrangements. So how many ways? So there are 6 slots. Okay, there are, let me write it, 6 slots for the vowels. Okay, so now number of ways the the consonants can be arranged is there are 5 consonants and you can arrange them in 5 factorial ways. So this is the number of ways you can arrange the consonants. So basically you play around with this DSCRT. Now number of ways uh, 3 vowels can be arranged in 6 slots. That is 6p3, which is basically 6 choose 3 into 3 factorial. And number of, but two vowels are repetitive. Repeating E. So if you see, the E occurs twice. So they are repeating. So for every such combination, we'll have to divide by 2. So therefore, total combinations, total arrangement will be 5 factorial into 6p3, or 6 factorial into 3 by 2, or 2 factorial, because there are two e's. So this is the total number of arrangements that we'll get, and therefore the right answer is option C. Does anyone have a doubt with this question? Okay. I guess we can move on to the next question. Okay. So coming to the fourth question. So in how many ways how many 4-digit numbers do all and only the 3 digits 279 appear? So what does this mean? So all of the three appears and only these three appears. So some examples would be, let us look at some example. So 2799 is a correct number that is being asked for in this question. 2729 is also a correct answer, but 2379, this is not a correct answer, because this violates the only part. Similarly, 2272 also violated, because it violates the all part. So here all 2 occurs thrice, but 9 does not occur. So in the 4-digit numbers 9279, only 279 must be present, and 279 must, and all of 279 must be present. It cannot be that one of them is missing. So how can we do that? So before solving this problem, so let us try it like this. So we have 279, and we keep a placeholder for the extra digit. So in how many ways can this be arranged? Arranged in how many ways? So you have 4 digits, so it is basically 4 factorial ways you can arrange them. Now for each arrangement, you can fill this slot 279, and this slot that we have, we can fill it with, so we can fill it with 2, we can fill it with 7, we can fill it with 9. So you have 3 choices. So that gives 4 factorial. So that gives 4 factorial into 3 arrangements. But we are counting some things twice. So things like this: 2799, this is one. And if we again count like this, 27 and 9 for this case, these are counted twice. So because every digit, one of the digit will be repeating. So you have 3 digits and you have to create a 4-digit number with only those 3 digits. So one of the digit has to be repeating. So in this case, so we'll have uh, we'll count the arrangement twice. So the total number of arrangement would be if we divide it by 2. So this would give 4 factorial is 24 into 3 over 2, that is 36. So the right answer for this question is 36. Uh, any problems so far? Okay. So let us move on. So if you have any doubt, you can ask at the end as well. Okay, coming to the fifth question. So, what would be the coefficient of x to the power 6, y to the power 14 in the binomial expression of 3x square minus 4y to the power 7 whole to the power 5? So, the binomial expression a plus b to the power n, for this binomial expression, the rth term is given by this formula. So, it simply you can calculate it. N choose r minus 1 with a to the power n minus r plus 1 and b to the power r minus 1. So in our problem, let us call this term as a and this term as b. So a is 3x square and b would be minus 4y to the power 7 and n is 5. So if we plug in, if we now we are looking for this coefficient. So x to the power 6 and y to the power 14 would basically mean we are find is x square whole cube and y7 whole square. So our n minus r plus 1 is 3. So x square 3x square is r a. So if we just look at the x part of it, so we are raising it to the power 3. So which means that n minus r plus 1 is equal to 3, where n is 5. So 5 minus r plus 1 equal to 3, and therefore r is also equal to 3. Now, if we now we have to find the coefficient. So uh, what is the coefficient of the rth term? So coefficient of rth term of rth term is n choose r minus 1, that is 5 choose 3 minus 1, that is 5 choose 2, which is basically uh, 5 factorial by 2 factorial into 3 factorial, that is 10. It comes out to be 10. And now we just looked at x and y. So a and b actually have coefficients of their own, 3 and 4. So to do that, so therefore coefficient of x6 y 14 would be, so we are raising the a term a to the power 3. So it is okay. So first we'll have the coefficient of the rth term, that is 10. Then we are raising 3 to the power 3 and 4 to the power 2. So that is 10 into 27 into 16. So uh, this is the coefficient of the x6 y to the power 14. So if you evaluate this, this comes out to be 4320, and the option D is the correct answer for this question. Okay, do you have any doubt so far?
I have one question in the previous problem. Why are we dividing it by 2? Can you please explain?
Okay, so in question number 4, this one.
Yes.
Yeah. So here, so what we do is first we consider a placeholder for the last for the extra digit for the 4-digit number that we have to construct. So if we take the placeholder and find the arrangement, we get 4 factorial arrangement. And for each of the 4 factorial arrangement in the placeholder, we can put 3 choices, that is 2, 7, and 9. So we have 4 factorial into 3 arrangement. But if you see such arrangements, so what happens is in this 4 factorial arrangements, you'll get some arrangements like, let's say this 2, um, 7, 9. So you have the placeholder over here, and you get another arrangement like 2, 7, and 9. So again, one more placeholder over here. But if we put the same digit here, so if we put 7 and 7, so basically these are the same thing, same numbers, because we can only put either 2, 7, or 9, so one of the digits will get repeated. So to uh, eliminate the repetition of counting, we'll have to divide it by 2 for the entire arrangement. So that is how you are dividing by 2.
Excuse me, sir.
Yeah,
Okay.
go ahead.
1 second, sir. This regarding fourth digit. Why can't go for instead of three factorial ways? Because
So
three numbers are there.
yeah, so you will get 3 factorial ways give you will not capture the slots in between this. So if you choose 3 factorial ways, so you will get something like, let's say, 279, 927, and things like. But we also want to keep a placeholder in between the digits as well, where we can fit the fourth digit. So it is not mentioned that the fourth digit will occur only at the end or at the front. It can occur anywhere in between. So first we are taking a placeholder for the fourth digit, finding all the combinations, and then we are filling the placeholder with the possible combinations, that is 2, 7, and 9. And then we are counting for redundancies. So by dividing by 2, we are checking for the redundancies. If it
Yes,
was
yes.
mentioned that the fourth digit was either at the front only or at the end only, then you could have gone ahead with the 3 factorial thing.
Okay, okay,
Yeah, yeah.
okay.
Okay, someone has said, so if we choose 3 factorial ways to arrange, then we also have 3 places out of 4, which makes it 3 factorial into uh, 4C3. Uh, uh, can you say like like Siddhant, I think. Can you just unmute and say what you are trying to say here?
No, sir. Here fourth digit, three numbers are there. Generally,
Okay.
when you go arrange three numbers means, so we can take 3 factorial.
Okay,
So, but
okay.
then I come to know that what after explaining. So here one digit only we have to choose, not three at a
Yeah,
time.
yeah, yeah.
Every time one digit we have to take. How many ways means only 3 ways, not 3 factorial ways. I understood like that.
Okay, okay.
It's clear, sir, for me.
Okay, okay. Thank you. So let us proceed on to the next questions. So coming to question number 6. So in question number 6, what are the properties of Pascal's triangle? So let us write the Pascal's triangle for a a few digits. So it starts with 1, then you have 1 1, you have 1 2 1, you have 1 3, yeah, 3 3 1, and 1 4 6 4 1, you have 1 5 10 10 5 and 1. So let us consider up till this much. So you have this four options. So sum of numbers of elements in each row is power of 2. So if you sum them up, it comes up to 1 2 4 8 16 32. This is the sum. If we check, it is symmetrical about a central vertical axis. It is. So if we draw a vertical central vertical axis, you see the left and the right side are the same, and it contains all powers of 11. So if we write as digits, as the as numbers, so you have 1 which is 11 to the power 0, you have 11 which is 11 to the power 1, you have 121 which is 11 square, you have 1331 which is 11 cube, and so on. So it happens that all three of them are true, and therefore the right answer is option D. So these are the properties of the Pascal's triangle. I think these are well mentioned in the lectures as well. We can also prove it. So if anyone of you is interested on how these are coming, I can discuss further on it. But for the question, this questions only, you need to know that all of them are correct for correct properties of the Pascal's triangle. Okay, moving on to question number 7. So we have a interesting question is how many ways you can go from 0 0 to 7 7 on a square grid without trespassing the diagonal and moving only up, right or up. So what this question means, uh, uh, okay, someone is asking for the C part of it. Okay, just going back to this question. So someone is asking how does it contain all the powers of 11. So the proof is very simple, is if you take, if you write 11, you can write it as 1 plus 10, right? So 11 to the power n you can write as 1 plus 10 whole to the power n. Now if you expand this, okay, we can do it over here. 11 to the power n is 1 plus 10 to the power n. So how will we write here? So we have n 0, I think 1 to the power 10 to the power 0 plus nc1, where 1 to the power n minus 1 and 10 to the power 1. And let's say we take nc2 and 1 to the power n minus 2 and 10 to the power 2. N by n minus 1 choose n, 1 to the power 1 and 10 to the power n minus 1, and you have n thing 1 to the power 0 and 10 to the power n. So these coefficients that you see, these coefficients, these are the elements of Pascal's triangle. Elements of Pascal triangle. Now if you look at these numbers, uh, these 10 to the power 0, 10 to the power 1, 10 to the power 2. So what these numbers basically do, they any power of 10, what they do is add zeros to the existing. So what it will create is, like, let us do for a simple case of, let's say, n equal to 3. I'll show you for n equal to 3, then you can see the pattern itself. So it will be n is 3 means n0 it is 1. So let me write first the Pascal's triangle, that is 1. If you see for 3 it is 1 3 3 1. So let me write it as 1 3 3 1. So in the first coefficient it's 10 to the power 0, which is 1. In the second it is 10. Third it is 100, and fourth it is 1000. So it's basically, you are, if you add it, the digits would be placed like this. So this would mean that you are placing 1 first, then 3, then 3, and then 1, and you have this plus sign in between these digits. So the tens basically add 1 zeros extra, and 1331 would, and since they are symmetrical, 1331 either ways it's same. So this turns out to be a power of 11. I hope you can see the point. Yeah, who asks this? Siddhant asks this question, right? So is this clear how it is coming out to be powers of 11? Yeah, okay. So I think it's clear. Then we can move ahead. Okay, coming to question number 7. So in question number 7, what we have is, in how many ways you can go from 0 0 to 7 7 on a square grid without trespassing the diagonal and moving only up or right or up. So for a, before solving it for a 7 7, so let us do it for a smaller case. Let's say we want to go from 0 0 to 3 3. So you have, let me draw some axis over here. So this point is your 0 0, and let's say this point is your 3 comma 3. So in how many ways you can go by take, you can only take right or up, and you cannot trespass the diagonal. So that, let me draw the diagonal. So this line over here is the diagonal. Now any valid path, let us draw any valid path, let's say. So wait, uh, let me highlight the grid. Okay, so this is the grid, and any valid path would look like this. So to go from, this is one right, we can take another right, we can go up, we can go up, we can go right, and again we can go up. So this is one valid path. So let us write it like this. So so R denotes one right step, and U denote one up step. So this path can be written as R R U U R U. So this is one example. So what do they mean by trespassing the diagonal? So anything like this, let's draw something like this. So let's say you have like this, you go like this, this. So the red line, this is invalid. So because we are crossing the diagonal. So first let us look at the problem without, we'll consider this trespassing aspect later. So basically, if we have to go from 0 to 700 to 77 by moving only up or right, so you get this combinations of R R U U R U. So if you look at this, so there are three R's and three U's. For a 7, for 00 to 77, we'll have any path. So you take any path that goes from 00 to 33, it will be some permutation of this R R U U, and there will always be three R's and three U's. Similarly, for 00 to 77, there will be uh, any combinations of 7 R's and 7 U's. So that gives us total of 14 factorial by 7 factorial divided by 7 factorial. This, so this is for R, and this is for U, and this one over here is for R plus U. So total there would be 14 steps in total. So it will be composed of 7 R's and 7 U's, but we do not know which order they will be. Uh, so someone is asking why did we use 14? So it would basically be 2n. So if you see this step for the 3 cross 3 that we have taken, so from 0 to 3 3, so any step that you take will consist of 3 R's and 3 U's. So the path can be specified by a string of 2 into 3 characters. So the total path is this R R U U. So this is the path. So the path can be specified by a string of 2 into 3 characters. So if it is 00 to 77, it would be a string of 2 into 7, that is 14 characters. Yeah, n being n, right? So the destination, I mean. So here in the diagram that I drew, n is 3, and for the problem that they have mentioned, n is 7. Okay, so now we'll have this many total number of paths, so that is 14 factorial, and why we are dividing by 7 factorials is because this all the r's are identical and all the u's are identical. So you have 14 factorial by 7 factorial by into 7 factorial. So this basically translates to 14 choose 7. Now comes the interesting part, that we cannot trespass the diagonal. So we'll have, so this contains paths that trespass diagonal. So we want to eliminate those paths. So we can't just do it divided by half, because there would still be paths for which it would cross the diagonal. So we'll have to do it in a separate way. So consider this red path. If you see the red path, and if I draw, okay. So for this invalid path, let me write down the path. So it is R, U, U, followed by R, U, R. So if we draw a barrier where the path is crossing over or trespassing the diagonal, so you see at this point, after taking R, U, and U, so after on this side it crosses the diagonal, and then you have some combinations of R, U, R. So if you see on this left hand side, you have one extra U. Now for this you have one extra R. So how, so we have to count these such paths and remove them from this 14, choose 7, the total paths that we can take by that we can take to reach from 00 to 77. So how will we count this invalid paths? So for that, a simple trick is applied, where we do a mapping. So where, if you see this path R U R, you can get a 1-to-1 map from to U R U. So you can basically, so all such paths, for any path that you take, and if you flip the U and R, so let me write it down. If you take any path and you flip the U's and the R's, you get another unique path. So it's not that if you flip it you can get multiple paths. So for every path, if you flip U and R, you get another unique path. So that is a 1-to-1 mapping. So let me write it down in words. For any path, if we flip U's and R's, we get we get another unique path. So using this property, so for the right hand portion of this invalid portion, so that is after the path crosses over the diagonal, so we flip this side to U R U, let's say. So we make this flip. So here we have one extra U. So this gives us a unique path. For, it's not that we are counting a different path. So therefore on the left side we have one extra U, and on the right hand side also we have one extra U. So in total we have two extra U. So basically the path is now split into, so paths that trespass is, so we have 2n factorial. So that is for n, that is the 3 or the 7. So we have 2n factorial on top. So again, there will, even if we flip it, so the 2n numbers that will be fixed, but we have n plus 1 u and n minus 1 r. So let me write it. So this is for u and this is for r. So that is the number of paths that will trespass. So the total number of paths that don't trespass is basically this 2n choose n minus uh, 2n choose n minus 1. So if we put n equal to 7, then we get 14 choose 7 minus 14 choose 6. That turns out to be this 429. So the right answer is option A for this question. If anyone has a doubt, you can go ahead and ask. So this gives you the total number of paths that we get without trespassing the diagonal. I think this is well explained in the lectures as well. So I'll move on to the next question. Okay. So which of the following is or are equal to the Euler number E? So you have four options. So the first one is basically the definition of the Euler number. So this is the very definition of Euler number. So it is limit of n tends to infinity, and you have 1 plus 1 over n and raised to the power n. So if we this is the original definition of the Euler number, and if we expand it using binomial uh, series, so let us for take the limit n tends to infinity and try to expand what this would look like. So you have n choose 0, 1 to the power n, and 1 minus n to the power 0, plus n choose 1, 1 to the power n minus 1, 1 by n to the power 1, and like this if we go on. So n choose 2, 1 to the power n minus 2, and 1 by n whole square. So it's a infinite series. If we now rewrite them, so if we take limit n tends to infinity, so what we are getting is n choose 0 plus uh, n choose 1 is basically n, and we are getting 1 factorial, and we have 1. For n choose 2, we have n into n minus 1 into n minus 2 over 2 factorial divided by 1 by n square, and so on. Sorry, this much. Now, if n is very large, so n choose 1 is this is 1. Let me write it this way. So this is 1. Here, your n and n gets cancelled. So this term becomes 1 over 1 factorial. If we look at this term, so this term is basically uh, n square minus n over n square by 2 factorial. So that is 1 minus 1 over n by 2 factorial, and so on. Now, if n is very large, 1 over n tends to 0. This will go to 0. So it's basically 1 over 2 factorial. And similarly, for the other terms, you can prove that they will be 1 over ith 1 over kth factorial for the uh, k for the k plus 1 term, the factorial would be k factor. So this is basically, we can rewrite this as sum of k equal to 0 to infinity of 1 by k factorial. So the the first answer is the correct definition, and if we expand it, it comes out to be b as well. So both of them are right. So the option c, this is not right, but this is equal to 1 over e. So if you expand c, and you will find that it turns out to be 1 over e. So if you multiply a and c, you will get 1. And d is obviously not right because we have a k factorial and here it's only mentioned k. Uh, I hope that's clear. Okay, so let us move on to the next question. So what would be the coefficient of x to the power 1, y to the power 4, z to the power 1 in the the binomial expansion? So it is not exactly the binomial, it's a monomial expansion. So 2x plus 5y plus 7z whole to the power 6. So so let us again write what is the coefficient of, let's say we call it x1 to the power n1, x2 to the power n2, and let's say x k to the power nk. So in the monomial expansion, in expansion of x1 plus x2 plus up till xk whole to the power n. So here it is implied that n1 plus n2 plus uh, up till nk would be n. So the coefficient is basically, you have n factorial over n1 factorial, n2 factorial, and nk factorial. So for our case, we have to find out coefficient of um, x, y, 4, z. So here we say n1 as 1, n2 as 4, and n3 as 1. So coefficient would be in the expansion. So just the coefficient would be 6 factorial over 1 factorial, 4 factorial, and 1 factorial. That is basically 6 into 5, that is 30. And now we have the 2, 5, and 7 as well. So the total overall coefficient would be 30 into 2 to the power uh, 2 to the power 1 into 5 to the power 4 into 7 to the power 1. So this is a very huge number, and this, if you calculate, it would come out to be this 2625000. So the right answer is option C for this question. I hope that is clear. Okay. Uh, Let us move on to the final questions for this session. So we have 3 students from class A and 7 students from class B who are taking part in a hackathon. So let us draw them. So you have class A and you have class B. So you have uh, here you have 3 students, A1, A2, A3, and Let's say you have here, you have B1, B2, B3, B4, B5, B6, B7. So you have seven students in class B. So we want, they are taking part in a hackathon where they have to form teams of two participants and compete against each other. So find the number of ways in which we can form teams where each class A student is paired with a class B student, and the remaining B students are paired among themselves. So there will be teams where it will be a mixture of A and B, or both are from B. So there won't be any teams where both are from A. Okay. So now let us proceed to solve this question. So so number of ways we can uh, 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 we can place uh, three students from B to pair with A. That is basically 7p4, which is 7 choose uh, sorry 7p3. So 7 choose uh, 3 into 3 factorial. So this is the number of ways you can pick three students from B and pair them with A. So we'll maintain the here, the order is also fixed. What we do, we fix the order of the students in A. So we have A1, A2, A3, and now we pick sequences like this. So if we pick like B1, it so a sequence may be like, let's say, B1, B4, and B6. We'll pair them with A1, A2, A3. So let me write it like this. So we fix the A's A1, A2, A3, and we pick any three from the seven B students and pair them with the students from A. So another possible order could be this: B4, B1, and B6. This is another pairing. Hence, we are choosing the permutation and not the combination, because the order also matters. So if in that's why the permutation is chosen. There could be other combinations as well. So B4, B5, B2. So this could be another possible. So this is the number of ways we can place three students from B to pair with A. So we basically, number of ways we can pick three students from of B is given by this expression. So now that we have paired three students of B with three students of A, now we are left with four students of B. So for each A-B pairing, so by each AB pairing means, so this is one AB pairing. So this can be another AB pairing. This is another AB pairing. So for each AB pairing, we have four students in B left. So now number of ways to split four students of B into teams of two is basically 4 choose 2, but that would count. So when we, let's say, pick two teams. So let's say we have left b4, b5, uh, b6, b7. So if we choose any two from this four, so let's say we choose b5, b6, this automatically implies that another team b4, b7 is being created. But in this 4 choose 2, we are also counting b4, b7, which again implies b5, b6 is being created. So we are counting the teams twice. So we'll have to divide it by half. So for each AB pairing, we'll have 4 choose 2 divide by half. So total combinations would be, you have 7 choose 3 into 3 factorial into 4 choose 2 divide by 2. So this is the total combination that we'll have, and this will turn out to be 630. So the option D is the right answer for this question. Is that clear to everyone? So we have covered the 10 questions from week 1 of the previous iteration. So if you have any doubt, you can ask me now, or uh, yeah, someone has a,
Sir, can you share this video?
yeah. So this will be uploaded to a YouTube channel whose link you'll find in the course web
Okay.
page.
Because when you explain little bit problem length more, we are not able to see that question.
Oh,
Once we
okay,
read
okay.
question means, then we can get some idea, no, sir. For that reason, I'm asking.
Yeah. So the videos will be shared and this PDF also will be shared with the solution. So the PDF that I'm showing to you, the document that also I'll be sharing with you. You can find this link in the course web page, but it will be updated by tomorrow. You
Thank you,
can
sir.
check it. Yeah.
Thank you.
So someone is asking where it will be shared. It would be given in the course web page. So if you open the course web page, uh, there is a section on the left panel that is problem solving sessions. So uh, that will contain the links to the YouTube video and the PDF as well.
Sir, another question, sir, regarding when problem given, especially in combination and permutations, how
Yeah.
to recognize one problem is a simple problem means we can come to know this, sir. When one problem comes means how we justify that if this is comes under permutation, this comes under combination. How we can identify, sir?
Okay, so the main difference between the two is in permutations, the order matters. In combination, the order does not matter. So if I give you, let's say, if I had this problem in this very problem, so if we had to pick 3 students from the 7 B students, so that would be a combination problem. So we pick any 3, it does not matter in which order we pick. We are just interested in picking the 3. But if I tell you that you have to pick it in such a way that you'll have to pair it with the students of A as well. So now in this problem, the students of A are in a particular order, A1, A2, A3. And so the order in which we pick the 3 students of B, that also makes an impact in how we pair them with the students of A. So this becomes a permutation problem. So this is how you recognize whether it's a combination or a permutation problem.
Okay, sir. Thank you.
Yeah. Uh, Someone had asked me is why did we divide by half? So in the last, I guess you're asking about here. So number of ways why we are dividing in half. So it's basically there are 4 teams left. So 4 members left in team B. So if we pick 2, it automatically implies that 2 are left. So if we have this, let's say you have, after pairing with students of A, you have left with B4, B5, B6, and B7. Now, if I tell you to choose 2 students, so one possible combination could be that you are picking B5 and B6. So which means B4 and B7 are left. But in while finding these two combinations, this 4C2 will also give you B4 and B7 as another combination. But B4 and B7 is already counted as a team while we found out B5 and B6. So basically we are counting it twice, that's why we are dividing it by 2. So the complement of it is also of size 2, that's why this is happening. So if it was more than 2, so if it was, let's say, instead of 4, if it was 5 students left in B, then we wouldn't have to divide it by 2 and it would have remained like this. It would be slightly different, but not exactly this, but you get the point, right? So when you are picking one, the other one is automatically getting created. Okay, so any more questions if anyone has? uh, why are assignment 1 and 2 both have same submission? So I am not sure about this. So that you can ask the course organizer. So my job is only to teach this tutorial lessons. I really don't have any contact with how this assignment deadlines are set. So if you mail the course instructor, maybe they will be able to help you out, or the NPTEL team would be better able to answer this question. I I don't have any authority in setting the submission deadlines. Okay. Any more questions? So yeah, so tomorrow also we'll have a session by a different TA. I think at the same 6 to 8 slot. So yeah, it they will also teach, I think, uh, uh, the same type of questions or a few different questions. So you'll get an idea. So hello, someone is saying I can't hear you. Am I audible?
Yes, sir.
Yeah, so uh, you'll get a different perspective on solving the question. So there are 2 TS for this course. So we'll independently solve these the assignment problems from the previous year, and you'll get 2 different perspectives. And if you have any other doubt, you can always mail us regarding your doubts, and we'll try to help you out. So I'll give my email ID in that problem solving sheet as well. You can find it over there. So will the same questions be solved tomorrow? So I don't know. So what he has prepared, I think it would be a bit different from what I have solved today. But more or less, he will solve from week one, uh, like content from week one. Uh, Okay. All right then. So if uh, is anyone trying to say something? Uh, okay, please suggest some books for the discrete mathematics problem. So, okay, so I haven't really, means I am also taking the course with it. So I am following the books that are given in the mentioned by the course instructor in the course web page itself. So let me share, let me see if I can give a screenshot of it. Wait. Yeah, so these are the reference that I am following for, that is given in the course web page as well. So will there be two problem solving sessions? Yeah, so there will be two sessions every week on one on Monday, one on Tuesday. Okay. Okay, then, if are there any more questions? If not, we can. Okay, so is class up to 8? So it's officially up to 8, but if we do not have any doubts, then we can close the session early as well. So if you have any doubts, we can discuss. But since no one has doubts, I think we can close the session. So someone is asking from 7 to 9. So this was the time allotted by the NPTEL organizer, so I haven't chosen this time from 6 to 8. So if you write to them about this from 7 to 9, then I think the next session, that is tomorrow's session, I think it can be changed from 7 to 9. uh, uh, okay, yeah. uh, Okay, so thank you everyone for taking the time to attend the course. I think we can close the session for today and see you again next week. So you have got another session tomorrow also. So feel free to join if you have any doubts. Okay, so uh, good. So goodbye everyone. So someone is asking, will there be a chessboard problem? Yeah, these problems will be discussed as we go down the course. So in further weeks, we'll discuss such problems. Yeah, yeah, I'll share the YouTube link of the class today itself. So I think by tomorrow morning you can see the YouTube link. Okay, okay. All right then. You can start leaving if you want. So someone is asking about the practice sheets. So these are available in the course webpage, or you can view the previous year's web course web page, and there you can see these practice questions with the solutions are also given. So just in NPTEL, view the this version of the course for the last year that was offered, and you will see all these questions. Or if you have any doubt, I can share these questions with you as well.